Okay, hopefully the sound is working, and I believe I'm on. Sweet. Hello, everyone. Uh, Thank you for joining me. This is the first on hopefully only a couple, maybe even more than a couple. Maybe I'm targeting three, but we'll see. Um, Streams on doing uh, Kubernetes the Hard Way by Kelsey Hightower on the IBM Cloud. Uh, I want to say that first, hi, I'm JJ. I'm a developer advocate for the IBM Cloud, and I'm going to be kind of going down on this journey myself to kind of learn what's going on. Um, I will say that I have done a small amount of research ahead of time, but I'm going in completely blind as just a end user to kind of see where it's gone. I know quite a few people have been successful with the Kubernetes the Hard Way, and they said they've learned a ton. So I've always wanted to do it, and now this is my chance to. So thank you for joining me, and we're gonna have some fun. I want to say that if you have any questions or thoughts, please don't hesitate to put your thoughts into the chat. I am here to figure this out, and I'm going to do the best I can to kind of vocalize my thoughts. I normally stream with a wing person or two. This is one of the first times I've really sat down and streamed just by myself. So there might be a little bit of hiccups here and there. But I'll start sharing my screen, and we'll start going from there. So let's kick this off. Okay. First thing first, I need to share my screen. Here we go. So if you don't know, this is the main site for Kelsey Hightowers Kubernetes the Hard Way. Now let me give you a little bit of a small amount of history here, just to kind of set the stage of the journey we're going to be going on together here. So back in the day when I was learning my way around computers, one of the projects I used to work on was something called Linux from scratch. Oops, Linux from scratch. And here it is right here. It's still alive and good. And it is what was the way if you wanted to learn how to do Linux from the ground up, it was actually one of the ways to kind of really understand what all the different packages were on the computer to build a Linux operating system. And by the end of it, if you actually did compile it and get it successful, you would have basically your own distribution of Linux. It was all built from source, and it was time consuming, not going to lie. As we've moved into the cloud native ecosystem and things have kind of been moved away from that, where people ran VMs and things like that, we kind of want to move into Kubernetes ecosystem. It's obvious that Kelsey kind of had either some inspiration or maybe there's some correlation between where he came from Linux from scratch into Kubernetes the hard way. This project builds a Kubernetes cluster on 6 VMs, basically on cloud. It's designed specifically for Google Compute Engine, but people have moved it into AWS. Other people moved into other different clouds. And my goal here is to get it to work on our Gen 2 VPC on IBM Cloud. So if you haven't seen it, once again, I'll just put the link inside of the chat so you can click on it and take a look if you haven't had a chance to. But it's basically just a straight tutorial of what you need to do. I'm going to be capturing my notes right here as we move out throughout the day, or the afternoon, I should say. And then I'm going to be doing the work in this window here. He tells you to leverage something called tmux to be able to do a lot of the cool work that we're going to do. So that's where I'm going to do it from. Hopefully this text is large enough for everyone to read, and we're just going to keep going. Okay. So, and if you haven't seen, this is going to be where I capture all my notes. I'm going to put all the raw notes up as soon as the stream is done. Then I'll come back the next day and I'll fill it out and or make it all a little bit cleaner so we can kind of see everything as it progresses. And hopefully in the future, someone will be able to either take what I've learned here to be a little bit, to go on the journey themselves, or for that matter, maybe even correct me, because then that means people are actually watching me. So if you don't know, we have something called the Gen 2 VPC infrastructure, and that's what I'm going to be doing. I'm going to be doing everything inside of this Asgard Labs VPC that we created on one of our developer advocacy accounts. And I'll spin up the machines when we start doing that in there. And this machine right here is actually is in the same VPC. So I'll be able to leapfrog into the machines that I need to as I build up the cluster. So let's take it from the beginning. Oops, that's not what I wanted. Ducks. All right, here we go. So the prerequisites. Kelsey tells us to use GCP. We're not. We're going to be using IBM Cloud, as I said. And this is all just kind of spinning up and making sure that we can talk to specific backends, just like we are here. He also suggests us using tmux. And as you can see, I am using tmux here. So that's good. And then just to prove to you, there we go. Here's my notes for today. And then here's a working, and then I can split as many times as I need to be able to SSH into whatever we need to, which is good. Okay. And then this most important thing is a synchronizing of panes. So let me go ahead and take some notes here. Enable synchronize sync of panes in tmux. I do love my markdown. Control plus B, shift plus, oops, that, and set synchronize panes. And then oops, on and then off. So now I know how to be able to, let's actually test this. So then I do Control B, Shift, set, synchronize panes on this. There we go. This is a test. Perfect. Good. So we don't need to worry about that anymore. Oops. Move that away. And then delete all of this. Perfect. I didn't actually turn it off, but that's not a big deal. All right. Synchronize tools, or only the tools. Okay, so we need to actually have something called CFSSL and CFSSL JSON to provide the PK infrastructure to generate the TLS certificates. Because I'm on a Linux machine, we are going to install the local client tools on Linux. Okay. And that is this. Copy. Put that there. And then we're going to chmod that. Copy. And then we are going to move that to where's our local bin. Okay, that seems pretty reasonable. Okay, so let's go back over here and go wget this HTTPS only, pull this directly down from what looks like an object storage from Kelsey. Okay, that's already a problem. Install wget wget. Okay, that's a problem. Oops. Wget. Let's just pull these two down. Copy. All right, so now we have, oops. RMCF SSL, CD, GitHub, SRC, GitHub, JJ, IBM Cloud, Hard Way, and then then .git ignore exp/. So what I'm doing here is I'm creating an experimental directory here. I put this up from I think John Calhoun, which is a Go developer. Basically, I'm just going to dump all my random things that I don't need to save on in the directory. Then I'm going to push up to here. So I'm just going to take the exact same thing I did a minute ago, and I'm going to copy that and then wget these things down. So now it's in this actual directory inside the same location. So instead of that home directory, I'm going to chmod these two files, just like he says here, to make sure that they're executable. Then I'm going to sudo move both of these into user local bin. Copy. And I don't remember what the password is for this one, so give me 1 second here. Let's see how far we get. There we go. Copy, paste. There we go. Okay, now let us verify our things are there. CF SSL. Okay. Version. There we go. It looks like this is the correct version. So source /zshrc. So then I should be able to do JSON version, and that looks like the same version also. Awesome. Okay, so let's go ahead and install some kubectl now. I'll go ahead and wget this down. Okay, and then I will chmod +x kubectl, and then I'll move kubectl into user local bin. And then we will do kubectl version. Oops, is it just version? I can never remember what it is. Oh, come on. Version --client. We are running 1.18.6, which is what we want. Perfect. Okay, so now according to this, we have the client tools that we needed to get up and running. Wonderful. All right. So let's create some compute resources. So this expects us to create a subnet specifically for this backend. So I am going to be hopefully not too lazy about this, and I am going to. This opens up a lot of things inside of it. So what I'll do here is, oops, this one right here. My subnet for this machine is sitting on thinking about it. Here we go. So maybe I can create a new interface with a new network. So let's do that. So what I'll do is I'll come over here and then subnets. I'll create a subnet here. And then this one. So this one's called Kubernetes. Kubernetes. And then on the Asgard Labs, good. I'm going to do 10.0.0. To 56. So it looks like I have to choose. So now this has become, where did my notes come from? Here we go. So created the Kubernetes network when instead of 10.240.00/24, we have to use, which was 10.240.128.0. Sorry, 129.0/24. It'll still give us the 250 addresses that we need, because that's what a /24 gives you. But we only have, yeah. Now I'm curious on why he has a /16 source range here, but we'll come back to that in a minute. So there we go. And I believe that's all I need to do. Creating that subnets, Kubernetes, that's backend, perfect. Now, what I'm gonna have to do is, I'm gonna have to do something a little uncouth, I know, but that's how we do these things. I'm going to right quit out of this, and I don't trust this completely. So what I'm gonna do, so I'm gonna come over here to the compute interests of this machine, and I'm going to add it to this new interface, to the Kubernetes, and I need to change these firewall rules. So let's actually create those firewall rules first before adding this to it. Security groups. I believe security group and firewall rule are more or less the same thing here. So we'll see how that goes. And it's just HTTPS, or asynchronous in that. So let's go ahead and create one. And we're going to call it Kubernetes the Hard Way. Oh, come on. Security group. Okay. And these are allow external. Okay, so internal, we're just going to add all protocols, TCP any to, there we go. Okay. Now we're going to add also this one to UDP of any to any, and then ICMP of any to any also. Okay, and then outbound, I'm going to do TCP port range of 22 to 22 to the destination of anything. I'm going to do ICMP from any, yes, to any. And then finally, I'm going to do TCP of 66443 to I am supposed to do all, but I'm trying to do exactly what the port is, and then work from there. I don't want to go too far off the rails. 6443, and then all to that. Let's see. All right. Okay, and let's create that security group. Okay. So then I can come back over to here and add this interface of Kubernetes to Kubernetes the Hard Way right here. And I don't think IPA, did it come up immediately? No, it doesn't look like it did. Did you source the range of 00 where you did the source of? I am not too sure. Oh, I don't think I did. Good catch, Sleazy. Good catch. All right, so let's go back over here. Manage these rules. Oh, yep. So the inbound. Yep. Ah, dang it. Good eye. Cider block. These two. Copy. Paste. Save. Do I need to, I guess I need to add two of them now, huh? Yeah, okay. TCP of any to base of this, save. All right, there we go. And then add. I'm doing exactly what he has here. It says allow TCP, UDP, and ICMP. I am very paranoid about doing it the other way. I want to try to do little changes from what he has to what we have here. UDP, cider block, paste, save. And then edit this one to cider block, paste of this one. And then ICMP, edit, and cider block, paste, save. Edit, ICMP, cider block, paste of that. Two to, of course, is not in order to do it. 24, yep. 24, yep. Okay, there we go. All right, so I added this to here. It didn't actually bring up the port because I don't actually know what's going on here. in the sense of like when I just added a NIC to a VM. I don't know how well it does. I'm just going to do a sudo reboot to make sure the machine comes back how I want it to, and then make sure that it does what I expect. It only takes a second because these are VMs, but it's one of those things that I just want to be in a clean state, not have to worry about it. So while that's coming up, then we are going to look at the next steps here. So that was a firewall rule. Then I had to create a external IP for this. I don't think I'm actually going to yet, mainly because I want to get the infrastructure up before trying to get the network to talk to it. So I'm going to skip the external load balancer here. Also, I don't actually know how to quite yet, so I'm gonna just kind of walk past that for now. Okay, so let's spin up our machines here. I know I have an IC command I can use for this, but I'm not completely comfortable we're playing around in that space right now. So I'm just going to go ahead and just spin these up by hand. It's only 3 machines, which isn't too bad. So we're going to call this controller 0. And we are going to do I have 18. Which is a little annoying. I'm not going to lie. I believe I can upgrade from LTS to 20, which is okay. Then let's see here. These are E2 standards, which are, I don't fully remember, but I'll go ahead and give it 16 gigs of RAM. And then I'll put my key in there. And then don't need to worry about data volumes. And then make sure we're in the subnet. Don't need to worry about some is there a way for me to give it a security group? And don't have, I'll have to add IPs to this. And how do I get into it if there's no, do I need to set up a DHCP server? God, I hope not. Let's find out. Okay, so that should have brought up this. Go back into the box. IPA. And here we go. There's the IP just as we were hoping to see. So rebooting the box brought it back up, which is good. All right. So src GitHub IBM Cloud the hard way, and then the raw notes of this. So then created a created VMs called controller 1 and 2 on the see if it comes up. go. That is what we're hoping to see. Okay. So if this is true, let's come over to let's say root at that ping this ping that. Never remember inet. There we go. It's on the same subnet, which is what I wanted, but I don't have. Right, this won't work because I have keys, don't I? Was I going to Ubuntu? I never remember this thing. Let's see here. Let's see here. Okay. Why am I not getting to it? Why am I not getting to you? VPN infrastructure, VPCs. There's the load balancers that I can come back to later. That's our labs. There was a view to make sure that they're actually, I mean, I know it says they're on the same one, but I just don't trust it. VPC lab, here we go. Make sure it's actually in the same spots. Kubernetes. There we go. So they're in the same physical network, which is fine. There we go. So they should be able to talk to one another. That's hence the reason why the IPs are fine. So then you come back over here. Why did you not do anything? If you're going to time out, it's not going to be great. Now, I could be somewhat lazy just to make sure that I can get to the machine first by giving it floating IP, maybe. Just put it on the outside world. Just kind of get into it. Because I want to get into it, but then that's not going to be, that's not really what I wanted, because I want to be able to go through this machine to do all the work. Okay. I'm trying to think here. So that did not do anything what I wanted it to do. Okay. Let's go ahead and give this a new IP. And then my local machine, root at this. Oops. I think I might be back to those security rules. Okay, so I was really not wanting to do, okay, so let's just do that, because I think I just opened everything up this way anyway. There we go, pings now work. Now I can go there. So if I come back over here, ping there, yeah, oh God. There we go. Okay, so I'm gonna be bad. I'm gonna be bad and not use that security group that we created. It was a little bit too restrictive. There's nothing else on these machines. And also you have to have your key to get in there. So I'm okay with being bad on this use case. Okay. All right. So we need to make, is there a clone button? That would be so much, so helpful. Of course there's none. So let's make controller 2. So we'll create controller 1, Asgar Labs. Going to be doing Ubuntu with memory, private IP of that. So create the virtual machine. And then I really need to figure out a way to do this through the command line. Controller 2, Asgar Labs, Ubuntu, memory, and create the first instance. There we go. So let those come up, and let's see what our next step is, shall we? All right. So now we need to create our workers, 0, 1, and 2. Okay. Worker 0, Ubuntu, memory. Create. Create worker 1. Excuse me. Memory. Create. And finally, worker 2. And Ubuntu, memory. Oh my good God. Oh, I haven't been changing the keys. Oh, come on. Come on, JJ. Oh my goodness. Oh my goodness. Oh my goodness. Is there a way to inject the keys? Oh, there is. Oh, come on. So don't want this one. Delete this one. Delete. Don't want this one. Delete. Delete. And delete. Okay, let's try this again. Controller, controller 1. Control. I thought they might be injectable, but I don't actually know. I've never actually gone through this interface before to build up machines. I actually ended up doing it through another way. So this is kind of my experience of playing around with this too as I'm doing this. But hopefully we won't have to touch this anymore after I do this. So this will be a non-issue, and we can worry more about it in the command line than the IBM GUI here. Okay, there we go. Got that there. There we go. And then number 2. We're 2. Memory. Key. Create. And let's do worker 0, flex, memory, key, don't forget that key, create, and worker 1. I've already lost track. Double check. Okay. Need worker 0. Yes, I do. Need worker 0. Worker 0. And then Ubuntu, memory, fix that key. And create. And then worker 2, worker 2, Ubuntu, memory, key. Yes, I know. That's why I changed it to worker 2. Thank you for catching up there. Create. Okay. So let's give this a second and have it come up here and do what we need. So let's see here. All right. Let's see here. And let's refresh. We should have all these VMs up and running. Possibly. Yep. That would be nice if I had all the VMs on showing. Here we go. We got worker controller 0, worker 0, worker 2. Just waiting on the next 2 controllers to come up. And we're off to the races. Then we have our machines. And let's just double check. I can SSH into this again because call me paranoid. There we go. And then we can try 13. Yay. Okay. We're getting somewhere. We now have our 6 VMs that we're going to be building the Kubernetes cluster, which is good to know. So let's see here. Refresh. Still waiting on these guys. I'm going to go ahead and SSH config. Shouldn't have anything in here. Good. I can never remember this. So let's see here. Window. And then just steal mine from over here. SSH config. And I am going to do. I'm going to do host controller 0 with the host name of this guy here, and then we are going to be going in as user of root for now. This could be different later, but 2, 3, 1 and 2, 11 and 12, 11 and 12, and then let's go ahead and come back over here. 1, 2, 3. And we'll create this to be worker. Oops. Ah, dude, that's so often it's unreal. And come back here. Oops, that's not what I wanted. Worker 1. Oops. And then do worker 2. And this should be worker 1 of 10. And worker, oops, no, worker 13. My mistake. 13. Worker 1 should be 10. And worker 2 should be 14. Okay, so then if I refresh this, still waiting on these to start up. What is going on? Kind of stuck until these are coming up. I'm pretty sure they're required. SSH controller 0. Oh, change mod 060 SSH config. There we go. That works how I expected it to. This won't work because it's not up yet. But I can go to worker 0. Good. And then worker 2. Yes. Good. And then worker 1. Yes. Ooh. That didn't. I did not call worker 1 correctly, didn't I? Let's see. Yep, didn't do worker 1 correctly. Damn it. All right. So let's delete this instance. Delete. This is why you verify your work. Create worker 1 in Asgard Labs, 18, memory, JJ, and create. Okay. This will change the IP, and that's okay. It'll be 15, and sh config. Worker 1 should become now 15. All right. So, where are the rest of my machines here? Let's see here. Okay, worker 1 came up. I'm going to give controller 1 and 2 just a couple more minutes, and then I'm going to nuke them from orbit and try over again. Ooh. What? One, 20, 50, 40, yeah. Yeah. There we go. Had to do some post-provisioning things, I'm assuming. That's okay. It's in the state I want to be in. And I'm going to go ahead and delete. Yes. And delete. Yes. And I'm going to create controller 1, Ubuntu 16, my key, create, and then controller 2, Ubuntu, memory, my key, and create. And let those turn green. And then we are off to the next portion. Okay. And this is just making sure that we can SSH into every single box, just as we were doing a moment ago, to make sure that that is there. Okay. So as soon as these are done, we'll be ready to start actually talking to these machines. SSH config. Controller 1 is 16. 16. And controller 2 is 17. All right. Go green. There we go. SSH controller 1. Still doing something. Controller 2. Still doing something. Let's give that a moment just now. If anyone has any questions or thoughts, please don't hesitate to put it in the chat. I do have it in the corner of my eye. I'm not paying attention to it as much as I normally do, just because, you know, I'm trying to do this. It's a little bit unnerving to try to have a conversation and do this at the same time. But I am going to pay attention to the chat. So let's see. All right, try this again. Just thinking about it. Thinking about it. We're at the post. No, that's right. Yeah, it's 16. Why was it going to 11? Did you see that? It's going to 11. Because I did the work visual. Damn it. 16, 17, and then back. And worker 1 and 2, 14 and 15. Worker 2 is 14. And then worker 1 is 15. Okay, so if I go to controller 1, yes. So controller 1, if I go to controller 2, yes. And there's controller 2. Wonderful. Okay, cool. So we can now get to all our machines that we want to. We don't need to worry about that anymore. Yes, we've that page. That is in a healthy state. We can actually SSH into all our machines from my little controller node 2. So now we are really starting to cook with fire here. GitHub, JJ, IBM Cloud the Hard Way. Go back into their experimental directory because I believe we are going to now start making some certs. Okay. 3 machines up. Everything in SSH in from the machine I'm expecting to. Oh, and just because I'm very, very paranoid, control 2. King, what was let's say worker 10, 240, 129, 10, 240, 129, 13. How about that? 13. And we can ping. Perfect. Okay. Now I'm really happy. Now I'm really happy. Okay. So let's provision a CA. Now, this right here is not accurate. Look at all these little tildes here. That's not good. Okay. First thing first. Created the VMs called workers 0, 1, and 2. Created a .ssh config so I can just SSH directly to them. Now, if you've watched any of my streams in the past, you know as soon as I find an issue in documentation or anything like that, it grates me the wrong way. I'm not gonna lie, it really does. So what I'm gonna do is I'm gonna do a hub fork here. Of course, they don't have hub fork. I'm going to fork this into my repo, and I'm going to put a PR in to fix that issue, and probably put some highlighting around it too because I like highlighting. So git remote add JJ Asgard. This copy paste. Okay. Now. This is number 4, so go to git checkout star typos format. Okay, and then go to docs 04. So you see it was right here. You look, that is broken. that doesn't do anything. Then there's this cat command, and then there's another cat command, and then you generate the CA and you create 2 files. So I am going to go ahead and delete those, take that, take bash there. So then you can copy pasta that if you want. And then this one, you also need to, that's fine. That does do nothing also. Then we should be able to say dash here because it gives you two files, which is what we're looking for. Okay. So forked and create started a formatting branch. That makes those commands into a single block in the, oh, really? Oh, interesting. So instead of creating two different files and 250U, it turns it into two. So it's using bash to do those things. Is that what you're saying? Oh, I didn't know that. Awesome. Okay, cool. Well, then I will totally do that then. Thank you for that. I'm not going to bother with changing any of this around just because honestly, I've always wanted to live in Portland. I felt very safe there back in the day. Granted, I mean, in the now times, there's a lot more going on in this world, but I still remember going around Portland. So, in honor of my brethren in Portland, I'll keep this there. Thank you for that, by the way. M5230U. Genuinely, I had no idea. Thank you. Okay. And it did, just as you said it would. That is awesome. I totally learned something new today, which makes life significantly easier. Yep, CZ exactly. Well, it's just an unnamed function running through bash. Granted, I am running Z shell. We're lucky that there wasn't such a bashism that didn't do something weird. But just because I'm paranoid, let's take a quick look at our CSR JSON there. Got CSR, and it is exactly what we're expecting. Awesome. Okay. So let's continue moving on. And we do have our two files here, LSL, as we have our CA PEM and our CA. Perfect. Okay. So now we need to create our admin client certificate. So I'm assuming this is the, excuse me, this would be in the real world, the key that you hide from everyone else. This is one of those things that maybe I should put that PR and turn it into bash anyway. That's me just wanted to put a PR in. This would be something you would hide from everyone. This is not something that you'd want to, obviously, because it's an admin key, but I'm going to grab it and then I'm going to copy it and I'm going to paste it. And it looks like it just did what I wanted it to. All right, it did exactly what I wanted it to. That is awesome. Okay, so now this goes in and creates, okay, so we need a kubelet client certificates. Uses a special purpose authorization I'm calling node authorizer that specifically authorizes the API to request by the kubelets. So I'm assuming this is like, by my understanding of Kubernetes, this kubelet client certificate is basically you put it on the kubelet and you have the other controllers who have it, and this is them authenticating, saying, absolutely, you are a kubelet that can talk to me. So very important. It looks like, oh, we need internal and external IPs because it uses G Cloud here to grab it. Why do I actually need to give external IPs? Like on the real internet? Did I miss that? Oh, it seems we are giving it real internet IPs. Oh. Okay. I missed that part. So let us go ahead and do this the slow, painful way. All right. Come over here. And these are the worker nodes. So refresh. So that one, and that one. All right. Let's see here. Okay, everything's coming up how I expected it to. And let's go ahead and CZ, you asked you need the real IPs for node port to be accessible. I'm assuming that's true. And then I put the external load balancer in front of them, maybe, I don't know. But I'm going to go ahead and give these all real IPs on the internet because I guess I'm going to have to. So let's create a new one and then create a new one and then create a new one here. And then we should need that. So I'm going to refresh this. You should see, there we go. There are 3 IPs. I'm going to move this over here for now. Just, I have an extra screen. I am going to have to do this because I guess I could do a for loop inside of a for loop inside of a for loop. But what I'll do is I will first, let's see here. So what I will do is for copy. Oops. Instance equals worker hash 0. And then we should be able to do this. Cat worker 0. There we go. We should be able to do worker 1. And then worker 2. I only have to do this 3 times, so it's not that bad. And then what I'll do is CF grab all. So I'll do external IP equals worker 0, which is this one. And then I'll do internal IP, which is this one. And then I'll do instance equals worker 0. And then I will do this here, this, paste that. So then I will go back up to external IP of worker 1 right there. And then internal IP of worker 1, which is this one. And we'll do instance equals worker 1. Yes. And then I'll go to the big guy and that. And I'll do external IP of worker 2 right here. And then do, I don't know why my control R isn't working. That's very frustrating. Internal IP of this one. Now I realize I'm doing this by hand and very slow, but also at the same time, like we missed the keys earlier, this is a really good way for me to verify everything's what I want, so I don't have to come back to it later. Worker 2, 14. Just like I just did here, this should actually be 14. Wow, I'm very glad I looked at that. And then instance of 2, and then I can do that. So we should now have ls-l worker star. We should see a key, a worker 0 key dot pem 0 key pem pane and a worker 2 and a worker 2 key. There we go. Okay. All right, we're getting there. M25OU. Can I ask why you're asking about the IBM Cloud SLVS detail? That's shooting me some information about the virtual server, though, because I'm actually using the Gen 2 backend, I don't use software. It's not actually software. It's another backend. And I think it's like IS, I think is now the command. That's the reason why I didn't do the research I had done. I'm sorry for that. And I'm doing it the slow way through the GUI and all. But it's one of those things. But yeah, so yeah, it's there's a whole like plugin for the IBM Cloud CLI for the Gen 2 that you have to install by hand to make sure that you use specifically Gen 2. All right, where are we now? Let me bring this back over here, and that was that other window I was looking at. Oh, that's not what I wanted to do. Put this back over here just in case we need it. So, okay, so let's now create the controller manager's client certificate. This looks like we do this, and now we don't actually have, we can just run it. Wonderful. Okay, there we go. So now we should have controller. We should now have a key manager and a PEM. And we got our CSRs from earlier. Okay. Now we need to create a kube proxy client certificate and key. So now what we've done, just to kind of reiterate, we're creating our client and server certificates. We created our admin client certificate to make sure that we're an administrator of on the client. We created our kubelet certificates, which will allow our kubelets to talk to, I'm assuming, our controllers. Then to identify each one of our workers. And then we created a controller manager client certificate. So I'm assuming that's how we can talk to each other's clients, question mark. And now we're creating our kube proxy client certificate, which will give us the opportunity to create kube client certificate. Okay, kube proxy, I'm sorry. Okay, we look like we're getting somewhere. And just to verify again, with -l proxy. And there we go. We're good to go there. All right. Now we're going to create our schedule client certificate, which I can trust will do the same thing. But we will just verify that it shows up again. So here we go. Okay. And then ls-l sched. And we've got our key and our PEM, which is wonderful. And just as a sanity check, back to scheduler, CSR, should be the same name. Well, it's like the same thing. Good. All right, we're making progress here. All right. The repo you're following uses the G-Cloud CLI. I thought it would be fair to use the IBM CLI to show folks how to use it. You are absolutely right. I should be doing that. The challenge though is that we don't have a one-to-one relationship with G-Cloud. The way the G-Cloud app CLI works, we would have to figure out some type of Rosetta Stone, which to your point would be well worth an exercise to figure that out. But I didn't want to spend the time trying to figure out the command. Like that's basically homework I've got to get done. I just want to get this working on the IBM Cloud first, even though I am doing it a slower way to do it. And then maybe after I get it successfully, because got to get it successfully done, then I can come back and attempt to fork this and use the IBM Cloud CLI commands, or fork it and create the IBM version of it that anyone can run through themselves. Okay. So static is including the list of objects. Okay, so now we need to create a certificate, API certificate. The static addresses will be included in the list of objects. Just to clear it up, I will show you. Here we go. This is the Gen 2 compute here. Right here, UPS infrastructure. So yeah, there it is. See, it's an IS command. So instead of using SL, which was a software, which was a classic infrastructure, you use the IS commands now to be able to interface with the Gen 2 backends. And it is a significantly better infrastructure than both the classic and SL infrastructure. So that's why I chose to do it here, which seems look great. If it makes you feel any better, M253OU. I actually do all my workshops on the classic infrastructure still myself, but this was one of the experiments here. Is me to learn how to use Gen 2 more effectively too, to be able to be more confident with it, because as we were discussing, this is a significantly better infrastructure, but this is my time to actually explore it too. Okay, and good old CZ is trolling everyone and trolling me in the background with Gen 2. Yeah, thanks. Okay. So now we need to create the API server. It looks like the static addresses will be included in the list of subject alternative names for the API server. So insert this. Okay, so it needs to make sure that the static IPs are actually there. This looks like there is quite a few ways to get this. So what I'm going to do is, looks like it's just a list. This public addresses is just a list of the IPs. I don't like how there's hard-coded IPs down here, because that's associates with the other addresses. So what we'll do is bring up our list again. VPCs. And there's bound to be a better way to do this. I know there is, but I'm sorry. Okay. So let's go ahead and then API cert.sh, then bash. Okay, come here, pull all of this in to this. Oh, of course I did that wrong. Set paste. paste that in there. Okay, now let's start from the beginning. Our public addresses. I believe this looks like it's just a list. Okay, good. So what I'll do is I'll delete that, delete that, delete that. Come over here, and our public addresses. And is this of all? Yes, it's all of our public addresses. So right now, just our workers have public addresses. Question to the audience: do you think should I add public addresses to the controllers too? Because my gut tells me I need to do that because this is pulling in from everything. Let's go ahead and do that anyway. Okay, cool. So I'm adding the IP or the public addresses now. New one down over here, and new one. Did I really just hit a limit on the IBM Cloud? Yes, of course I did. Okay, so I ran into the max number of IPs I could have or declare for them. So hang on. Yep, OU, I'm just gonna call you OU from now on because I'm not gonna read out your number every single time. You are absolutely right. So we do need to add them. So I'm gonna go ahead and grab this one. And then I'm gonna come over here and grab this one. And there we go. There we go. There we go. Good. Okay, so if I refresh this page, delete all those. There we go. We all have our IPs now here. Okay, so let's go ahead and grab our first one right here. And then our next one of this one. And this one. And this one. And then this one. And then this one. Okay, so that looks like we have all 6 external IPs that we're expecting. Good. Now, host names look fine. Now let's come down over here. Ooh, what is that? What is going on? Okay. Now this here makes me curious. 10, 11, 12. That smells like specific machines, doesn't it to you too? Let's see here. You think those are the worker IPs? I think you're right too, CZ. But I want to just verify. God knows I don't want to break this out of the gate. Here we go. 10, 11, 12. Yeah. Oh, no. Oh, they're the controller IPs. 20s are the workers, controllers. So our controller IPs are 10.140. So let's do 129. Yeah, 129. 129. 129. And our controller IPs are 6, 16 and 17. 16 and 17. Okay. All right. Just to verify, 6, 16, and 17. Okay. All right. Now I'm not too sure what this 1031 address is. Maybe that's the whatchamacallit, the load balancer you created that we kind of skipped past. Ah, there we go. Private network right there. Firewall rules, network. There is compute instance, verification. This is Hill. Did anyone see where'd the load balancer go? It must, no, it's an external IP. Okay. Not too sure where that 1032.1 is coming from. Not ecstatic about that, but let's keep pushing forward. As my British friends say, let's keep cracking on. Oh, here we go. The API automatically assigns Kubernetes internal DNS name, which is linked to the first IP address 10 from the address range reserved for internal cluster services during the control plane bootstrapping lab. Oh, so it's on like section 8. So we haven't actually seen this. It's well farther into later on into the actual project. Okay, good. So we're okay with that. Okay. So -x API search. Okay. So PS or ls-l Kubernetes. We now have a Kubernetes PEM that was made just on this minute. Okay. All right. Now we need to create a service account key pair. Here's how to manage service account. Seems reasonable. Anything unique out of this? No. So let's just go ahead and grab this, paste, and build. And we can do ls-l service, and we got our service accounts. Wonderful. Okay. All right. And for instance, in worker 0, worker 1, worker 2, do scp ca.pem to instance key.pem to instance.pem $instance done. There we go. Okay, so we've successfully now got our CA and our keys for our our workers distributed to our backends, which is good. Okay. Then we need to copy our things to our controllers. So for instance, why am I copy paste right there? Come on, it exists for a reason. Okay. Then do scp ca.pem ca key.pem Kubernetes key.pem and Kubernetes hem JJ, come on, service account key.pem service account.pem to $instance oops, to there and done. Okay. All right. So now we've created all of our keys that we needed to, or at least it seems we have. We've sent out our keys and our PEMs to our workers from our own CA, our certificate authority. That is something that I really do want to learn much more around one day, is how to like run a good CA. That's something I've just never been able to get my head wrapped around. And now we've sent out all of our keys to our remote controllers too. Okay, and it looks like the kube proxy, controller manager, scheduler, and kubelet client certificates will be used to generate the client authentication configuration files in the next lab. Wonderful. Okay, so I have been pushing about an hour and a half right now. I don't know if you can tell, but my voice is getting a little bit raspy. So I'm gonna go grab myself a drink and get myself to stand up for a few minutes or so. But I will be back in about 3 to 5 minutes. I'm gung-ho, I'm still going on this. I just need to get some water. So please stick around and I will see y'all in just a couple minutes. So thanks for sticking around, or thanks for just joining me. We are I'm assuming well on our way to getting Kubernetes cluster built on the IBM Cloud using Kubernetes the hard way. So this is we'll see how. Let's keep going. I brought myself some string cheese too, because one of the great things about being a dad is you can have string cheese in the house. Something I do truly love. Okay. All right. So next step, we're going to be generating the Kubernetes configuration files for authentication. Now, remember, that was a nice big blob we did. So less vim API cert. There we go. There's our public IP addresses. So I'm going to go ahead and grab this because we will need that. So what we're going to do, get our public IPs, and we're going to kubelet configuration file. When generating the kubelet configuration files, kubelets, the client certificate matching the kubelets node must be used. This will ensure kubelets are properly authorized to authorizer. The following commands must be run on the same directory used by to generate the SSL certificate during this. Okay, good. So again, I've done everything inside of this EXP directory. So this looks like it should grab everything we need to get done. Now, you look here. We're going to generate this. We still have, wait. This address grabs all the addresses, right? Because, I guess we should. I mean, do we do a list of the public address? No, that can't be right. Use that server HTTPS : / a bunch of IPs : that can't be right. That has to be one, right? Or am I wrong? It doesn't seem right. Oh, wait. This is a VPC static address. So when I kind of slip past this, I need to create this a public gateway. There we go. Yep. Here we go. So that's it right there. That is the public address of our network there. Okay. So I'm going to do this. Oops. Oh my God. Come on. I'm going to go here, copy, and then equals back over here. This one to that. Okay. Then nothing else so out of the ordinary, right? Okay. Let's grab it. All right. So ls-l ls-l kube config. There we go. There are 3 kube configs. Okay. Now, echo dollar Kubernetes public address is still there. We're going to join it for the kube's proxy service. Grab our CA, kube proxy. I'm just assuming it just keeps concatenating this thing, right? Worker 1, kube config. Yeah. Still don't like that, but that's fine. If we need to change it, we know how to change it, which is okay. Okay. So we'll grab all this again. It's all just one command. Okay. Oh, whoops. Okay, so I made a mistake there. ls-l kube config. rm. That. Run that again. Now we come over here. These guys. Copy. There we go. Now we look. Kube proxy. Kube config. There we go. Okay. All right. Next, kube controller manager Kubernetes configuration file. We're going to grab anything unique out of this. No. Okay. Copy. And then paste. All right. And then just to verify, ls-l manager. We have a kube config right there, 39 passed. Yep, that's about right. Okay. Scheduler. Nothing that looks too crazy. Okay. Good. All right, now we're actually creating user configs now. Create a kube config for the admin user. CA, client certificates, context, user admin. That's the money right there. That little line gives you all the rights to this cluster whenever it gets up and running. Okay. Now we need to distribute the Kubernetes configuration files. Okay, so this one, come on. Admin. Kube config. There we go. Okay. Here. Copy. SCP. Instance. Kube config. Excuse me. Kube proxy. Kube config to $instance home, done. Okay, now we got our kube configs, our YAMLs, because I believe they are YAMLs, distributed with the kube proxy also. Okay. Now let's get the controller pushed out there. SCP admin.kubeconfig kube controller manager.kubeconfig kube scheduler kubeconfig to the home directory of instance. Done. Okay. All right, so it looks like we've created all our certs, and we've now created our kube configs, and we've distributed them how we needed to. This is assuming I've done this correctly. Granted, this is all just configuration, but it's enough of the configuration to make sure that we have correct communication between the 6 different VMs we have. Okay. All right. We are on number 6. Out of how many? I don't actually know. 14. Okay. So we're about to hit the halfway mark. Okay. So what we're going to do is we're going to create our encryption config and key here. We need to create an encryption key. I always find it fun to kind of run these first just to kind of see what they do. So let's actually run it. And that is a crazy key. That's how keys are fun. Okay. So let's create one of our encryption key. Let's see here. Okay. And then we're going to create an encryption config.yaml. And then we are going to create our secrets and our main key here. Okay. So cat, all of this in here. Looks good. Okay. And then we're going to ship our key to our controllers. SCP encryption config to instance here and done. All right. So believe it or not, we have hit our halfway point where we have actually gotten to the point where we've got all our configurations done, and now we've shipped everything around, and now we're actually going to start bootstrapping portions of the cluster. Just take a moment. Yes, it did take a little bit of time to get here, and we did walk through quite a few different things, but I genuinely am happy with how far we've gotten right now. So let's actually start doing some more work, shall we? Okay. So these commands must be run on each controller at the same time. So let's play with some tmux, shall we? All right. I'm gonna open up a new pane. It's called a pane. I think it's called a pane. Split that window, and then split that window. Now, if I remember correctly, there is a command size equal. There's a way to make these equal. tmux size equal size panes. There we go. Select layout even horizontal. And of course I get it wrong like I always do. I always get horizontal and vertical mixed up. Don't tell my kids. Vertical. There we go. Okay. Now, I need to do back forward. Okay. So then set, what was it? Synchronize pane on. LS. Okay, cool. So we now have our 3 machines, SSH controller. Damn it. Off, 0, 1, and 2. On. All right. Top-C. We see our machines all up and running as we like them to be. Okay. All right. Here comes the fun parts, everyone. And quick little aside. Okay. We are going to wget these down to the home directory. Copy. Okay. So wget this. All right. Then we can do this. Okay. Now, etcd is just a binary. If you've never looked into etcd, it is a distributed key value store so when you start learning more about Kubernetes, you quickly realize that etcd is basically what Kubernetes is. It leverages etcd significantly. It is the heart that beats quite a bit of Kubernetes. Hey, I work with him. He's a good dude. Slava. Yep. So if you have a chance, spend a couple moments researching it and learning a little bit about it. It's well worth your time. Okay. So we have now put it in the workspace. So we are going to create an etcd directory, varlib, change mod, and then put our PEMs into etcd because that is where it's going to be running. So copy. They're running sudo. I don't like this. Because I'm root. That shouldn't matter. No, that shouldn't matter. Okay. All right. Now, the internal instance address will be used to serve client requests and to communicate with the etcd across two peers. Retrieve the internal addresses of each of these machines. Okay. Do that. So we do that. So if I do echo $internal IP, nothing comes back. I was not expecting that. Okay. What does this thing actually do? That's not a real what the? Why am I going to an internal Google site? Anyone else see this? That's not cool. Let me think here. Oh, probably because it's on. That's not. It's because it's on Google Cloud, right? That's probably a Google Cloud thing. So it grabs the internal IP. So if I do IP A, grab inet. Star 240. No, that would be too easy. Grab 240. Then awk print or print $2. I know this is bad. Leave me alone. Awk -f slash print $1. There we go. Okay, so then we can come back over here and say internal IP equals that. Then we can do that, and now we got our internal IPs. Like I said, not pretty, but it worked. Okay. Where are we? Let's see here. Now, each Etsy moves to a unique name for Etsy cluster. Okay, that seems like a reasonable thing to do. Echo and $Etsy. Those are all unique names. Now I need to create a systemd unit file where bin Etsy internal IPs, yes. That, boom, that's something we need to fix. Okay, what I will do here is everything else looks okay. So I'll grab all this, copy to all of them. I'll come over here, copy to another window, paste. Okay, so controller, damn it, paste. Okay. Let's start at the beginning. Controller 0. Controller 0 is 6. 129.6. Controller 1 is 1, 2. Controller 1 is 16. 129.16. Controller 2 is 17. 129.17. Okay, now I will grab all of this, go back to this, paste. Okay, come back here, grab all of this, and then end of file. Okay. Seemed too easy. Cat Etsy systemd system etcd service. Oh, it's all there. All right. So then let's start etcd. Yes, WX. Let's see. Oh my God. I think it's working.
Excellent.
I got etcd up and running. I am actually flabbergasted. I am genuinely, and no joke, like I am very, very shocked that I got etcd up and running. This is amazing. Okay. Okay. All right. Okay. You ready for the Kubernetes control plane? Yeah? I think I am. Let's give this a shot. Okay. So now on each of the controllers, should I wait? Should I pick this up next week here? I mean, I feel pretty good. Do I really want to push this harder? And it's just hit 2 hours. Yeah, I'm thinking I'm gonna pick it up here. I'm gonna pick up this on the control plane next week. Yeah, I'm gonna do that. I don't want to push myself too far, and also this would be a good place to stop in case you're watching this at a later date. So thank you everyone for on this journey, this first part of the journey with me. I will be picking this up again next week. Same bat time, same bat channel. Thank you so much. And I will talk to y'all later.